Hello everyone, this is Mr. Hebner with Notes at Night, and it's a late night for me. It's actually 10:55, which is an hour and 25 minutes past my bedtime, but that's okay. The kids are asleep, and that's a good thing, and it's well past the time that my migraines tend to disappear. This is like the third time I'm doing this video, because first time I didn't have the recording going, but the recording's going this time. Alright. Then the second time it deleted it because apparently my wife has 50 gigs of pictures and I didn't have space to save it all. So I had to transfer those. But we're good now. Alright, anyways, enough of that. This is Notes at Night, and we're going to be doing it on the metric system. But before we talk too much about the metric system, I want to talk about some basic things like chemistry. What is chemistry? Alright, so if you can open your, note packet. We got some pretty pages. Look at that. My very first chemistry notes. So for a lot of you, you may not have done chemistry before. So these are your first notes. And what fitting definition for your first definition than the word chemistry? Alright, this would be the time if we were face to face, I would ask people, what do you think chemistry is? And people would raise their hand. I would say, Tommy, what do you think? And Tommy would say, well, I think chemistry is, I don't know what it is. What is it, Mr. Hebner? Well, chemistry is the study of matter, its composition, structure, properties, and the changes matter undergoes. So we'll quickly summarize that by saying chemistry, and you don't have to rewrite chemistry, it's just late so I did it. Chemistry is the study of matter and the changes it undergoes. There it is. And that's essentially what we're going to be doing in this class. We're going to be studying matter and changes to that matter. Alright. Well, speaking of matter, what is the definition of matter? And does it matter? Okay, moving on. So matter is anything that has mass and takes up space. There it is. Hey, there's the definition. Boom, right there. Anything that has mass and takes up space. Alright. Hey, the next word's the metric system. You guys heard of that before, right? Well, the metric system is used by most of the world. It is based off of units of 10. Based off units of 10. It's internationally understood, and it's overall simpler. Unless you were born in America and raised on the English system, then it can be kind of confusing, but it is simpler if you compare the two systems. So, why don't we talk about the English system first. In the English system, we have things like a yard. So in football, football field is 100 yards. Our rulers are 12 inches. So a yard is actually measured on King Henry I of England, the distance from his nose to his middle index finger. So that full distance. The problem is, King Henry lived a long time ago. So long ago that his bones most likely are dust. So do we really know that a yard is a yard? I don't know. We can't go back and confirm that. And then a league, distance that equaled an hour's walking. I'm 6'3", my wife's 5'2". If we both walk an hour, I'm going to walk a longer distance. We know that because when we wear Fitbits, she has more steps. So if I'm, well, I was going to say if I'm lagging behind on my steps, just have her wear it. I'll delete that right now. All right, now that I deleted that last part, going on, an acre, it's the amount plowed in a day. Are we talking about a tractor, a donkey, a mule, or a horse? I don't know. It's all relative. A furlong, the length of a plowed ditch. L, the distance between the elbow and index finger. Of who? That's the English system for you, and that's why only 3 countries stick with it. Those countries are Burma, which was held under an obscure dictatorship for quite a while, Liberia in Africa, which haven't heard much about what's going on in Liberia, and then America, because in America we do what we want. And we've been able to do that because we've been the sole superpower for quite a while now. However, there's rising powers such as China, and they're on the metric just like the European Union and everyone else. And when kind of the powers of the world equalize a little bit more, America most likely is going to have to conform to the world community in terms of using the metric system. So I imagine in our lifetimes, we're going to see kilometers instead of miles per hour on the road signs. I think they'll probably phase in by having both of them at the same time, because I might get pulled over for speeding and not know why. Yeah. Okay. Moving on. Oh, no, not moving on. So we're on the English system. We got to talk about the metric system. Why does the world use it? Because it's simpler. It's based off of units of 10. And in the next video, we're going to see how it's simpler. There's patterns to it, whereas the English system, there aren't really any patterns. It's obscure. All right. So what we got right here is a nice little box from a textbook. There are some inaccuracies in it that I will point out. That is why we're going to fill this box in together. It's kind of like a match. Why would we do this? If it's right there, I can just snap a picture of it. Well, studies show that if you write things down, you're more likely to remember them. And that's the whole purpose. Because we're going to be using these base units quite a bit. There's 7. 2 of them are specific for physics, those bottom 2. We're going to ignore those. All right, so the first one is length. And the symbol is L. And the unit is meter. And the abbreviation is little m. Then we got mass. The little abbreviation is hyphened, not hyphened n, but italicized m. And we're dealing with the gram, not the kilogram. That's kilo is a prefix, which we're going to talk about in a later video. It's gram. So there's errors in textbooks. And then it's not kg, that's kilogram. It's just g, which is gram. And we got time is in big, no. Little t. What was I doing? Huh. All right, and it's second. And little s is that. There we go. Then we got temperature. And that's going to be big T. It's in Kelvin, not Celsius or Fahrenheit. Kelvin is based off of absolute zero, the theoretical coldest temperature that could exist in the universe. And we've got big K for the abbreviation. Amount of the substance is the last one. And this is unique to chemistry, because chemists are all about knowing the specific amount of a substance. And that's N is the symbol, mole is the unit, and to shorten that up a little bit, it's a long word, so we put MOL for the abbreviation, because M was taken by meter, so we got to do something different for mole. Those are the 5 base units, so you're going to want to memorize those. There's going to be a quiz on knowing what these base units are and what their abbreviations are. Taking a step back on why the metric system is better than the English system, we got a little slide right here, and this shows how it is consistent. No matter where you are in the universe, or for that matter, when you are in the universe, it will always be confirmable, consistent. So right here, 1 meter is essentially the distance that light travels in 1/300 millionth of a second. That's not going to change no matter where you are or when you are in the universe. A kilogram is this hunk of metal that's sitting in a vault in France that a bunch of scientists said that's going to be a kilogram. So you can go back and confirm it, right? Yes, it's not a biological organism that eventually decomposes to dust. It's a hunk of metal. It's always going to be there. A second is based off of the radioactive decay of cesium-133. Is a second always going to be a second? Absolutely. And the list goes on. You can always confirm them no matter where or when you are. All right, moving on. There it is. We got to do the next thing, which is units of volume. So these are good to know. 1 liter equals 1 decimeter cubed. So a decimeter cubed is a decimeter, height times length times width, and you get a cube, 3-dimensional square. And 1 liter is kind of what we use in AP chemistry. 1 decimeter cubed is what we use in IB chemistry, American version versus international version. 1 milliliter, same deal, is equivalent to 1 centimeter cubed, also known as 1 cc, centimeter cubed. That's doctor speak, nurse speak, stuff like that. Moving on, density. So we're going to be doing a lab on density, a couple of them. So density equals mass over volume, and you can think of it as really sad actually, because density, it equals a broken heart. It's mass over volume. So if you think, because I don't think if you don't remember it, you can ask me. I'll probably tell you, it equals a broken heart. Mass over volume. So just kind of a mnemonic device to help you remember that equation. Speaking of density, we got mass versus weight. I mean, we talked about matter being the amount of anything that has mass. It takes up space. Well, mass is the quantity of matter. Whereas weight is the gravitational pull on matter. Feel free just to pause this video if you need me to slow down. You could also change the speed. I don't know if you can change it slower. That would be kind of fun if you could. Alright, so mass is the quantity of matter. How much matter is there? That's what chemists are concerned with. Whereas weight is the gravitational pull on that matter. So when we're in the lab, I'm going to use the term, you need to go mass that chemical. You need to go mass. I'm not going to say you need to go weight it. I don't care about weight. I'm not a physicist. I'm a chemist. Think about it. Neil Armstrong is one of the few humans to go to the moon, and when he was on the moon, his mass did not change. He was still Neil Armstrong, same one that was on the Earth. But his weight did change because he was on the moon, and the gravitational pull of the moon is much, much smaller because it's a smaller celestial body. So, long story short, his weight got less, but his mass remained the same. So, alright, one last thing. conservation of matter. Conservation of matter is huge, or it's also known as conservation of mass. Huge, huge, huge chemistry concept. You can't really do chemistry, the science, without this foundational law. Law of conservation of mass states that matter cannot be created nor destroyed. This is one of the answers on the test. The next test you're going to take. What is conservation of mass? Well, matter cannot be created nor destroyed. Matter cannot be created or destroyed. That is the conservation of mass. All right. I think we're going to take a pause on that. The video is about 15 minutes so long. We'll do another video, but that was Notes at Night. I hope you enjoyed it. I'm getting a little tired, but I'm feeling like another video. I think I'm gonna crank this one out. I'm gonna do another video. So either have a good night, good day, or watch another video. But I'm gonna sign off this one.